All right, starting the year off with types of numbers. Real numbers is what we're talking about. There are different kinds of numbers besides real. We'll learn more about that as we go. But everything you've seen up to this point mostly has been a real number to you. So I kind of have a little story that goes along with it to make it a little bit interesting. I just kind of say, like, you know, like way back in the day, there was like two dudes, Dave and the other guy. The other guy never has a name in this story. But it's like one day, way back in the day, Dave and the other guy were like underneath an apple tree. And all these apples were on the ground. And the other guy was like, yo, Dave, I wonder how many apples that is. And Dave was like, dude, I don't know. We don't have numbers. And the other guy was like, yeah, maybe we should like invent our numbers. So they invented numbers, and they started counting up all the apples. And the way they did it is just the way they taught us to count when we were like in kindergarten and stuff. If I asked you to start counting, how would you start? 1, 2, 3, 4, 5. Isn't that natural for us to do that? Those are what's called the natural numbers. So the natural numbers are our counting numbers. And if we write them as a set, we'd put this cool little set bracket, and we'd put them in there like 1, 2, 3, 4, 5. And that would go on forever and ever and ever and ever. And there's a symbol for that, which you've seen before. It's the double bar N for natural numbers. So you make like a normal N, and then you just put this second little bar in there, the double bar N for natural numbers. Because if we start counting, it's just natural to do that. But then in Dave and the other guy, they had them apples. They counted them up. It was a weird thing happened. They ate them all. And they're like, hey, yo, how many apples are there now? And the other guy's like, dude, I don't know. They're all gone. So they needed to invent another number. And since they're all gone, we know what number they invented. What did they invent? 0. Right? So no more apples. So that didn't fit in the old natural number system. So they created the whole numbers. And the whole numbers is totally 0, 1, 2, 3, 4, all the way up. And it's got a weird symbol. You may have had a math teacher totally tell you to put a W for whole numbers. That's actually not right. So they were just kind of like making it easy for your brain. I like to do things right. The symbol for the whole numbers is a double bar Z, which stands for integers, and then greater than or equal to 0. So this says all the integers greater than or equal to 0, those are called the whole numbers. And if you look to the left here, I've got a little Venn diagram going on, but it's like the circles are inside of each other, because here's the natural numbers. All the natural numbers are actually inside of the whole numbers. And I drew a little map. It's kind of like Hayes. Hayes is the place that we're at, but would you believe that Hayes is also inside of Ellis County in that situation? So even though there's other things in Ellis County, you know, like Ellis and all those cool little cities like Munger, Shench, and Catherine, it's just that Hayes is a part of that. So the natural numbers are a part of the whole numbers. And then what happened was they needed to invent some more numbers, so they invented the negatives. So they took all the naturals, like 1, 2, 3, 4, and did their opposites. So you get like -1, -2, -3. And the problem is that could go on forever to negative infinity. And then we still go all the way to positive infinity. So now we're going like forever and ever and ever in both directions. And those are called the integers. That's the symbol with the double bar Z. So every natural number is an integer. Every whole number is an integer in that case. But the integers just have a little more. Just like Hayes is in Kansas, Ellis County is in Kansas, but there's also just a little bit more stuff going in that. So like the integers is like Kansas, the whole numbers is like Ellis County, and Hayes is like the natural numbers. It's like you're just fitting inside of each other as a set. And then rationals, keyword, and that is ratio. If I say ratio, what kind of comes to mind? Like a fraction? So a rational number can be anything that is written as a fraction as long as the numerator and denominator are like integers. So simple thing, 2/3 is an example. 1/2 is an example. But rational numbers are the ones that we get wrong the most because people think that it could only be a fraction. If you see a fraction, they think that's just a rational number. You could also have a terminating decimal like this, 0.5. Isn't 0.5, like we all know what that is as a fraction, right? Isn't 0.5 totally 1/2? You could have 0.75, And what I mean by terminating decimal is like it doesn't go on forever and ever and ever and ever. Like when you punch it in the calculator, it doesn't like just go on forever like pi. You remember pi, like just like 3.14159, blah, 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 blah. Another thing that a rational number could be is a repeating decimal, like 0.3 repeating, because I think we all know that that's 1/3, right? You know, so like that can be a fraction. Or any kind of repeating pattern, like 0.1212121212. Any kind of repeating decimal is still a rational number. But the thing that throws most people off is, what if I put 7 in there? Do you think 7 could be a rational number? Discuss with your neighbor. Is 7 a rational number? Can you write 7 as a fraction? Isn't that totally 7 over 1? So every integer is actually a rational number. Just like if the rational numbers were Kansas and I went to the set bigger than that, like the United States, isn't Kansas in the United States in that situation? So the symbol for the rationals is the double bar Q. You make a capital Q, and then you just put a little staff going up and down. And then finally, the weirdos. The weirdos in the real numbers are the irrational numbers. Irrational mean, or ir kind of means it's not. It's just like it's not rational. So if the rational is any fraction or any terminating decimal or any repeating decimal, the irrationals are the weirdos. I have given you one example. That was pi. Pi was an irrational number. Other examples are like square roots of non-perfect squares or something, like say the square root of 2. If I totally punch in the square root of 2 and see what it is as a decimal, it will give you a nasty, nasty decimal that does not have a pattern to it whatsoever. It does not repeat itself, and it goes on forever. Some people think it just ends after that 9th digit there. Nope, it keeps going on and on and on. So could you and your neighbor maybe make up another one? Just use another square root, you know? Like what's another square root that you know it's not going to come out nice? Talk about that with your neighbor. Kind of nasty, nasty radical. And there's others. We'll learn. But the irrational symbols is the tough symbol. It is the real numbers. Do you guys remember the real number symbol from back in your Algebra 1 days? What's the symbol for just real numbers? Double bar R. It's the real numbers take away, and in math language, this backslash right here means like take away the rationals. So it's the reals take away the rationals. That's weird. Reals take away the rationals. But if I called this, you know, like humans right here, and these were all the boys, and these were all the girls, could I totally say that the girls could also be like humans take away boys? You know, it's like if you had all the humans out there and you took away the boys, wouldn't you just be left with the girls in that case? And yes, I do know that people can be born with same-sex origins and organs and stuff like that, but in a general sense, it's like if you had all the humans and you took away the boys, you're pretty much left with the girls. So if you had all the real numbers and you take away the rationals, aren't you left with the irrationals? So that's pretty neat. And then finally, the real numbers is everything. Everybody that we've talked about. All your reals, all your rationals, all your irrationals, integers, whole numbers, etc. So let's dive in here. They ask us to identify the set of numbers to which each number belongs. Well, I came up with an acronym. I do that a lot. You know, like you've probably seen some other acronyms, like have you ever heard of Roy G. Biv, to like remember the colors of the rainbow, and like every good boy deserves fudge. They taught us that in music class when I was a little kid to remember the scales, or please excuse my dear Aunt Sally to remember the old. It's an acronym. I do really quiet zebras won't neigh. You might want to write that down. That's up to you. Really quiet zebras won't neigh. So you can pause the video and write that down. And the reason why I came up with this acronym is because these are the letters, kind of all of our types of numbers if you stay on the rational side. R for real numbers, Q for rational numbers, Z for integers. Then I slipped this as a W just to kind of help remember that it was whole numbers, even though the whole number symbol doesn't have a W. Neigh. Really quiet zebras won't neigh is the way I like to think when I'm trying to see if this is a number. So, weird at first, but they are asking us to classify -11/3 as from least specific to more specific. first start with real. Is negative 11/3 a real number? The answer will be yes. Every number you've heard of to this point is a real number, right? So this is a free point right here. We will put both the symbol and then we'll put his name in parentheses. And for those who have never had me before, I am serious about this. If I show you how to write an answer, that's how I will grade it, right? So if I said just put the symbol in the name, please do it like so, okay? But you'll learn as we go along. Then you've got to ask yourself what it fits into after that. So again, back to my boys and girls example. If this was all the humans right here, then, okay, if we're going to classify it any further, you got two choices. Is it a boy or is it a girl, right? It's humans, right? So is it rational or is it irrational? And this guy, the irrationals are the weirdos. Pi, square root of 2, square root of 7, stuff like that. This is a normal number, right? You know, it's not weird. Isn't it a fraction in that case? So what do you think? Is it rational or is it irrational? This guy is rational. So we'll go with a Q. So really quiet. And then it's rational. Then I'm on to zebras. I want to check to see if that's an integer. Right? So I checked to see if it was a real number. It worked. I checked to see if it was a rational number. It worked. Now I want to see if it's a zebra. I want to see if it is an integer. Of course, we wrote this down for a reason, so we could look at it to help ourselves, because it's been a long time. Does negative 11/3 fit into this definition? The natural numbers, 0, and their opposites. What do you think? No fractions allowed for integers. So this is as specific as it could get in that case. It's a real number, and it's a rational number, and that's it. Okie dokie. Then I look at number 2, and I want to see if that can simplify first before I do it. It says the square root of 25. Just because it's a square root doesn't mean it's nasty. Does the square root of 25 actually simplify? It is really the number 5. So let's talk. Is 5 a real number? You bet your biscuits. And then you got to choose, is it a boy or is it a girl? Is it rational or irrational? 99% of the numbers that we're going to deal with are on the rational side. The weirdos have to go to the irrational side. 5 is a really nice number, right? So isn't that in the rational category? I could write it as a fraction. So really quiet. Then I go for zebras. Zebras is integers. That's the Z, right? Is 5 classify as an integer? Looking at my list of examples, would 5 fit into this set? What do you think? Sure would, right? Because it's going on in this 1, 2, 3, 4, 5 direction. So he's a zebra. Integer. That's the most misspelled out of all of these. Integer. Then I want to see if 5 is a whole number. So that's the W. Is it a whole number? Does it fit into those categories? Yes, it does. So we'll put the weirdest symbol of them all. The integer is greater than or equal to 0. He's whole. And then there's only one thing left. I've done really, quiet, zebras, won't, nay, N is for natural. So is 5 a natural number? If you was to start counting, would you naturally run into 5? Yes. So that was everybody. Double bar N. I'll do one more with you. Even if you had absolutely no clue, you should never leave a problem blank for me, especially this. Always take a guess. Think about real. Could we at least realize that this is going to be a real number? So we'll put that on there. And then you decide with your neighbor, please. Is that rational or irrational? Irrationals are the weirdos like pi, square root of 2, square root of 7, square root of something non-perfect square. You guys remember what that bar means? What does that bar mean up there? That it's the negative 4.17 repeating that, sorry. Yeah, I think. It's told everybody was out. I have been in it. So negative 4.17, repeating is what that means. What do you think, rational or irrational? That is rational. And then when you're stuck on your own, Please use the acronym to help you if you need it. I've done really, I've done quiet. Now I got to go check everybody else. The integers. Integers, if you want to think of it in your like own words, then integer is like all the whole numbers plus their negatives, right? Does this guy fit in the integer category? Is this like a whole number or a negative of a whole number? Integers, make a note if you want to. No decimals, no fractions. If you want to know that in your own word, an integer is no decimals, no fractions. Since this has a decimal or a fraction, it's not an integer. Integers are no decimals, no fractions, baby. So we're done. I will let you pause the video and try to do number 4. Classify 0 from least specific to most specific with your neighbor. Do we feel that 0 is a real number? Definitely. All the numbers on this list are going to be real. Is he rational or irrational, though? What do you think? Where would 0 fit, on the rational side or the irrational? He's rational. Is 0 an integer? You could look to your examples. You know, when you do your homework, that's why we take notes. Also look to it. Is 0 an integer? Yes. Is 0 a whole number? Yes. Is 0 a natural number? So he's everybody but the naturals in that case. One more of those. Let's do 19. Classify him. If you want to pause the video and try that one, you definitely know he's real, so we can start with that. So here's what I got. 19 is definitely a real number. It is also rational because it could be written as a fraction. It's 19 over 1, you know. And it is an integer because it doesn't have any decimals or fractions. You know, no decimals, no fractions. It's okay that you put it over 1. It's definitely a whole number because you would reach it, and it is even natural. If we started counting and I just let you go, you would naturally come across 19 when you started counting those. So, pretty basic, eh? If you just kind of follow the old acronym. Problems like 6, though. 6, people just look at it, they see the square root in there, and they're like, nope, that's going to be irrational. We got to simplify it if possible. It's 36, a perfect square. Remember, perfect squares are two numbers that multiply together to be the same thing. So like 6 times 6 is 36. So this is really 6/9, which can actually reduce to 2/3. Please classify him. 2/3. You'll always have at least 2 answers. Real is a given. It's a real number. And then you have to put them in the category of rational or irrational, right? So you'll always have at least 2 answers. The fact is, if you need to go further than that is the question. So is 2/3 going to fit into the integer category? When integers definition to our layman's terms is no decimals, no fractions. Isn't this totally a fraction in this case? So is 2/3 an integer? Not going to fit. And then the last one is pi. We know he's real. And then you got to classify him as either rational or irrational. That's the most obvious, irrational. The symbol is what we kind of get wrong. Sometimes people like put them backwards. They do Q/R. We will take a homework quiz on this next time, and it will be over the weekend, you know, so we'll have to refresh our memories when we come into class, look things over, but this is irrational. I'll ask you a good one, just like out loud. We don't have to write anything down, but what do you think about pi over 2? Would that be like a rational number? Is pi over 2 a rational number? It can't be, because to be a rational number, both the numerator and the denominator have to be integers, and like pi is irrational in the first place, right? So it's like you can't be a rational number and have an irrational inside of you. Even like square root of 3 over 4, it's like, dude, even though that's a fraction, it's got an irrational number in it, so he is irrational in that case. So nice. All right, to the backside, little translation of English words into mathematical symbols. If you like to highlight, you might grab a highlighter. There's just a couple things in here, but you don't have to. But here's 2 phrases right here. You could circle them if you highlight. Circle or highlight the phrases more than and less than. And less than are what we call backward phrases. I'll explain that when we get to it, but basic words, which we definitely different, minus, you know, it's like all these mathematical phrases here. So and, plus, sum, increase by, more than are all for addition. minus, difference, decrease by, less than is subtraction. And multiplication, times is pretty obvious. Product, you know, it's been a while, a few months since we've been in school, so product means multiplication. Of, that's a tricky one. A lot of people didn't realize that of means multiplication. If I said take half of 6, you like multiplied those numbers together. Half times 6 to get 3. So half of 6 is 3. And the division, divided by, obviously, quotient is the cool math word for division. Also, add the phrase out of. I didn't put that on your worksheet, which I did, so I made that change. Out of. If I said 9 out of 10 people agree with this situation, that's like a fraction in there. But what do I mean by backwards? Here's what that means. Is like we will just translate all of these English words from left to right. We will just literally translate this. Unless we run into those phrases, we have to switch things around. So let's see what that means. First of all, the sum of. What does that mean that we will do? The sum of. That means we will do addition. So I know there's going to be addition, right? 6 times a number. Well, here's what we're doing. We're going to let x stand for the number. You know, like they just got some number. We're going to let a variable. So 6 times a number and 25. When I read through all of this, did you ever see more than or less than? Those two phrases in there. Were they in there at all? So no backwards phrases. That means the order that they type this in is the order I'm going to write it down in. 6 times the number comes first, it will be put first. 25 comes second, it will be put second. I didn't need to switch the order of any of those terms in that case. So the sum of, please add together 6 times the number, so we'll call that 6x, and 25. Right, so that's just from left to right, pretty much translated. We'll do number 9 here. 4 times the sum of a number and 3. So interesting. 4 times, we definitely know we're going to have a 4. Times a sum, though, if you're going to multiply times a sum, that is a secret way to say, please put parentheses in there. 4 times the sum of a number and 3. So sum means I need to add together a number. What do you want to call that number? Since they don't tell us, what would you like to make up for it? X and 3. This is probably one of the trickiest ones out of all of these. To take 4 times a sum or 4 times a difference. If you're going to multiply something times a sum or multiply something times a difference, that means that stuff had to be in parentheses in that case. So 4 times the sum of a number and 3. Notice no backwards phrases in there either. So I put everything in the order that I saw it in. But 7, bing, less than 15 times a number. First of all, less than is totally different than is less than. Remember these symbols? If my pen would work. Less than and greater than, or less than and equal to and greater than or equal to. These have is in front of them, like it is less than or it is greater than. This just says less than, so that means subtract. So we're going to do subtract. But should I write this stuff down in the order that I see it, or do I got to do a little backwards operation? This is a backwards phrase. So here's the 7. Would you believe it's on the left side of the less than? I need to put it on the right side of the subtraction sign. 15 times the number is on the right side of the less than. I need to switch it around. So anytime you see that less than or more than, those are the only 2 phrases that are backwards in that situation. If I told you I had $100 and Wyatt had 10 less than that, you would have to take what I have and subtract away 10. Right? So you have to kind of think about it in reverse. You have to know what you had first to subtract that. Please try number 11 with a neighbor, or pause the video, I should say, and we'll talk about it. Give it a shot. Just give it a try. It's okay if you don't do it right. We'll fix it. To talk about what the square of a number, I'll give you 2 choices. We'll let the number be x. Sound cool? So does that mean this in purple, or does that mean this in green? One of those is right, and one of those is wrong. And like I said, it's been a while, right? Which one do you feel? Tell your neighbor first is right, the purple one or the green one, the square of a number. What do you think? It's the green one. But this one's pretty understandable. What does that symbol mean? It doesn't mean square, it means square root. So it's been a while, right? No big deal. So we don't want the square root. If they wanted a square root, they would have had the word root written after that. So we need 4 times the square of a number. How do you feel about throwing a 4 in front of that? All right, 4 times the square of a number. Okay, like I said, there's no backwards phrases in there, so I'm just reading this from left to right. 4 times the square of a number. Help me with increased by. What does that mean? Plus. 5 times the same number. So the number that we did was x, right? So we just got to do 5 times that. 5 times x, if my pen would work. Do I need to put parentheses around it? No, because they would say like 4 times the sum of the square of a number, and that's 5 times. So they didn't say like times and sum kind of right in a row, like how they did here. Times a sum, or times a difference. That's when you'll need parentheses, when you see like multiplication of addition real quick, or multiplication of subtraction. So it's all good. The correct answer was this guy right here. That's why answers are free, if I didn't talk about that last time because I rushed through it. I've got our homework today. We'll have plenty of time in class to work on it. If you want to come check yourself to see what's going on. We learn from trying and we learn from checking and that stuff. So here's our answers. And then finally, just some basic solving equations. Definitely know what we're doing. So they want us to solve for a. Here it is. It's actually a minus a. Got to get rid of this 9. How do we get rid of that 9? And what I care more about is your organization, guys. Like some math teachers let you get away with just slopping stuff down. Some of us are very, very bright and can do this mentally. You know, I totally feel you. But I need to see just not all this work shown. I need to see organized work. So I'm going to subtract 9, and 17 minus 9 is 8. Equal sign nice and lined up with the other equal sign, and negative a is what's left. And of course, we get rid of the times negative 1 by dividing by negative 1 and get a negative 8. I definitely know we know how to solve that equation. It's just, you see how organized I am with my equal signs like all nice and lined up. Feel free to ask a question if you had one. Here, t's on both sides. Let's get the t's on one side and the numbers on the other side. It does not matter where you move the t's. You can move the 6t over to the left, or you can move the 5t over to the right. I'm going to move the 5t over here, so that way I still have a positive amount of t's. So that means negative 1 is still here. And 6t take away 5t is 1t, which you don't have to put the 1. Please put a little tail on your t's, though, a little curly thing. You know, it's called a tail, so it doesn't look like a plus sign. And minus 5. And then we'll add 5 to both sides and get 4 equals t. Just so it doesn't look like a plus, you know. T's are a hard variable for math. Those are real basics. Number 14, would you believe that that is a fraction equal to another fraction? There is tons of ways to solve this, but the way we have really shown you is to do a little thing like this. Anybody remember what that's called? Cross multiply. You can totally cross multiply. Like I said, it's not the only way, but we'll cross multiply. 2 times 2 is 4, and there's an m with it. The m is up in the numerator because it's like the m is over 1 in that case. So it's m over 1, so the m is in the numerator. So 4m equals cross multiply 3. And then we would get rid of the times 4 by dividing by 4. And I'm a big believer of fractions. Although 0.75 is correct, I would rather it be written as 3/4. This is not a story problem or anything like that. So when we just do an algebra problem, I like fractions as much as we possibly can. And number 15, anybody remember what this thing's called? If you had to do this, what's that called again? Distribute. You could do that if you wanted to, and I will let you. You could also get rid of this times negative 2 by dividing both sides by negative 2 first, if you wanted to. But I think we'll be more successful if we just distribute the negative through. I'm a big z crosser. I like to cross my z's so they don't end up looking like 2's. So whenever I make the letter z, I put a little staff in it or cross it. And then I'll add 14 to both sides. Don't be afraid to use a calculator. You know, that's why you bought one. That's why you have one. You know, you can do mental math. Great. You might want to do some mental math sometimes and check it by punching it in. So that would be 6 equals negative 2z. And then finally, z equals negative 3. Questions about those? Pretty basic. And then the old fractions. since this cannot be cross-multiplied because it's not just a fraction on the left side equals a fraction on the right side, there's tons of way to do it. What I usually suggest is clear the fractions. I'm just going to take everybody times whatever my least common denominator would be, and that would be times 2. So if I take everybody times 2, that's going to make life a lot cleaner for me. So the times 2 and the divide by 2 are going to cancel each other out, and you're left with 5n. And then you just got to distribute the 2 to everybody else. So 98 times 2 would be 200, take away 4, which is 196. Minus 2n. And then add the 2n over. That's our other thing. It's just the sign errors. We're all guilty of making sign error. You know, just take your time. The faster we go, the more sign errors we make. But you had to add 2 over. And then if you guys would help me out, does 196 divided by 7 come out nice if we punch that in? How much did you say? Thank you. If it didn't come out nice, then you could change it to a fraction in that case. So let me show you how to do that real quick on the calculator. So let's say that wasn't 196. Let's say that was 198. Let's 199. So if I got 199 and I divided it by 7, that is not nice. But there's a function on the graphing calculator, if you have one of these. We call it math enter enter. So there's a math button right here. You'd hit the math button, and then you just hit enter twice because the function says change it to a fraction. Yes, I would like to do that. And it would totally reduce the fraction for you right away. If 199 over 7 reduced, it would reduce it. So let's do like maybe 9/6. 9 divided by 6, it's going to give you this. Math enter enter. So math enter enter. It'll say 3/2 for you in that case. So only one more. Why don't you and your pal get that guy done? Solve for n. So is what I'll have, right? And then I'll check to see if I can reduce that. I can pretty much see that like 3 is going to go into both of those guys, but if I use my cool little calculator tool and just math enter enter, I can reduce that to 11/2 because 3 went in each one of those guys. So 3 went into 6 twice, and 3 goes into 33 11 times. By putting 5.5, it's not wrong, but I'll just get you to correct yourself that it's like, did I do something wrong? Everyone's looking at it weird. Did I make a mistake? Okay. I do that. I do make mistakes. So, but if you put 5.5, I would probably start putting some notes on your homework quiz. It's like, please leave this as a fraction. That way when we take our test, you'll know. This is just a plain algebra problem. No stories involved with it, so I like to keep those fractions. Nice. Let us know if you have any questions. Have a good one.